Okay, so hi guys. For today, we will have the continuation of the topic that we had discussed last time, and this includes stoichiometric problems, wherein we're going to deal with the problems that requires the conversion, just like mole to mole, mass to mole, and mass to mass. So um, this is quite hard discussing these topics because it really requires the whiteboard and the whiteboard marker, and it is easier to discuss in front of the class, but I will try my best to explain it to you in my own way. So please have your periodic tables ready with you, your calculator, and extra sheets of paper so that you can uh, you can follow the things that I will do here in the video. So the knowledge that is required for this lesson are molar mass, which is already discussed to you last lesson, and at the same time you also need to learn all about mole ratio, and that will be discussed first before the stoichiometric problems. So mole ratio, technically, what is mole ratio ba? By simply looking at the balanced chemical equation, just like here, I have here butane added to 3 molecules of oxygen gas produces 2 molecules of carbon dioxide and 2 molecules of water. Basically, this is a balanced chemical equation. So, ano po ba yung mole ratio na tinatawag natin? So, ang mole ratio po ay yung ratio ng bawat component sa isa't isa. So, we are going to look at the coefficient, yung number na nasa unahan ng bawat component, just like this one. We have 2, we have 3, we have 2, we have 2, and we have 1 here. So, automatically, kapag walang nakalagay na number dyan, that is 1. So, so mole ratio. So, let us try to look for the mole ratio of in this balanced chemical equation. So, for example, if you're going to look for the ratio of butane and oxygen gas, so that is 1 mole of butane, or C2H4, over 3 moles of oxygen gas. So that is one mole ratio. Another one, let's have the ratio of oxygen gas and carbon dioxide. So that will be 3 moles of oxygen gas over 2 moles of carbon dioxide. So as simple as that. So why do we need to have this mole ratio? It is because these will be used as the conversion factors in solving the different stoichiometric problems. There are several problems here that requires you, or that will require you to use mole ratio. Some will require you to use the molar mass, and there's also one which requires you to use both. Okay, so we need to understand this first. So what are the mole ratios that we can have in this balanced chemical equation? So another one, we have 2, let us have carbon dioxide and water. So that's 2 moles of carbon dioxide over 2 moles of water. Basically, there are a lot of mole ratio that can be found in this balanced chemical equation. You just try to look, and it depends on the problem. So it depends on the problem on what mole ratio you are going to use. So we have 2 moles of water over 2 moles of carbon dioxide. We can also use 2 moles of water over 1 mole of butane. 1 mole of butane over 2 moles of carbon dioxide. So we have a lot of mole ratio that can be found in this problem. Another one, let us try to have this a balanced chemical equation. This is quite this is a large one because as you can see, the coefficients here are large enough. You have 10, 15, and 30, but we have 1 here. So let us try to look for the possible mole ratios. So just like here, we have 10 HSiCl3 over, or 10 mole, sorry, 10 mole over 15 moles of H2O. That's one. That is one of the mole ratios. So another one is 1 mole of this one, Si10, sorry, O15 over 30 mole of HCl. That's another mole ratio. We have 15 moles of H2O over 1 mole of H10 Si10O15. So that's another mole ratio here. So we can also have 10 mole of SiCl3 over 30 mole of HCl. So we can find a lot of mole ratios in a single balanced chemical equation. So you need to explore more and understand the problem itself so that you can easily find what mole ratio is required or you need to use in the problem. So I hope you learned about mole ratio because as you can see, we are going to use this topic, or we are going to use this knowledge as a prerequisite in solving different stoichiometric problems. So that's mole ratio.